let's discuss what happens when waves run into things. When waves hit solid things, when waves hit other waves, when waves transfer from one medium to another. All right, so what happens when waves hit something solid? Well, when they hit something solid, waves have a tendency, waves will put some energy into the solid object and will reflect off it. All right, so some of the energy wave will be absorbed into the solid, and some of the energy will be reflected back in a wave form. Okay, so we can think of a few. Light reflects off almost everything. Right, but black objects reflect less light. They absorb more of the energy. Black objects absorb more and reflect less. Sound waves will reflect off objects, and we'll get something called an echo. Right? If the sound wave reflects off an object that is solid enough, it will send the sound wave back and we'll get an echo. So that's sound bouncing back. Now sometimes when a wave hits something solid, it causes that solid object to vibrate at the same frequency as the waves. So sometimes a wave will cause a solid object to vibrate at a specific, at a matching frequency. And this can cause all kinds of problems. The Tacoma Narrows Bridge is an example. If you look up a video of the Tacoma Narrows Bridge, the wind caused waves inside the bridge itself, and the bridge fell apart. When soldiers walk across bridges in groups, large groups, they march out of time so that the vibrations caused by their stomps, their marching, won't cause the bridge to vibrate and maybe vibrate until it collapses. You can shatter crystal glasses by getting them to vibrate at a specific frequency with a specific sound. This is called resonance. So mostly we think about the reflecting off of it, but sometimes you get this resonant effect where everything vibrates to match the wave that's hitting it. So the incident wave is the wave that... So let's draw an example of this. We've got a person on a cliff here. And there's another cliff. This person sends out a sound wave. Hello. The incident wave is the wave that goes out. That's the initial wave. The wave before it hits the object. So in this case, this is the incident wave here in blue. Now, after this wave hits this canyon wall, this wave comes and is reflected back. So the wave is then reflected back and you hear the echo. Because we know the speed of sound in air, you can figure out how far away this is based on the echo, how long it takes for the echo to come. So the reflected wave is the wave after it hits the barrier. Now, naturally, this reflected wave will have less energy than the incident wave. So your echo is going to be a little bit quieter. Some of the energy goes into the solid. We'll look more at wave reflections in the next section. All right, what happens when they hit other waves? So waves can hit other waves as well. And they can do a few things. They can cancel each other out, or they can build each other up. Constructive or destructive interference. Waves can interfere. Okay, so there's two types of interference. Constructive, which is like building up. And destructive, which is kind of like canceling out. Now, this happens a lot when you get someone who's driving a boat and they've got a tube rider on it. The boat goes around and they spin around in circles. And they look for where the waves meet. And where the crests of two waves meet, you get a much higher wave. Then you try to bring the tube over top of that much higher wave. This is also used in noise-canceling headphones. Noise-canceling headphones will try to do destructive canceling out of sound waves. Now, here's a bit of constructive. Okay, so I'm just going to have a half wave here traveling this way. So I've got a half of a wave traveling here. And I've got another half of a wave traveling here. Let's say that both of these waves are 1 meter tall. What happens when they hit? Well, so this is step 1. Step 2, when they collide, you're going to get this gigantic 2 meter tall wave. And then in step 3, those two waves are going to continue past on their own. So you can see this one will go back down to 1 meter. Keep going that way. And this one will go back down to 1 meter, and it'll keep back going that way. So the waves will approach, they'll join, form a big superposition. This is called a superposition. And then they'll go on. Now what happens when we have opposite waves come? So here in step 1, so this will be destructive. Step 1. We've got a 2 meter tall wave going this way, and coming at it from this side is a 2 meter trough. What happens when those two meet? On step 2, when those two meet, you're just going to get a flat line, and you're going to cancel out the waves. But then, as they pass each other, you're going to get the 2 meter trough, still going that way, and you're going to get the 2 meter crescent, still going that way. So they'll come together, they'll cancel out, and then they'll go by each other. Right now this works, and it just adds up. Like if we have a 3 meter crest, if we have a 3 meter crest meeting a 2 meter trough, when they meet, you get a 1 meter crest, get a 1 meter high wave, so smaller. So where two troughs hit, it gets bigger. Where two crests hit, it gets taller. Where two troughs meet, it gets deeper. Where a crest and a trough meet, you get less of a wave. So two crests get taller. Two troughs meet. It's going to get deeper. And one of each, it's going to get smaller. Right? So that's wave interference. And two good examples are making waves on the water and using noise-canceling headphones. Okay, so interference here, so we can do, we just talked about that. Let's talk about a standing wave. A standing wave is when it looks like a wave is not traveling. This is pretty easy to do with a rope and two people. Okay, so if you got a rope and it's attached here and attached here, and then you send a wave the wave will go down, it'll hit this end, and then the wave will bounce back. And it'll go down, it'll hit here, some of the energy will be absorbed, and the wave will bounce back. When the energy is absorbed, you see the amplitude will shrink a little bit, right? Because that's less energy when it comes back. So you've got the wave going down, the wave coming back. Wave going down, wave coming back. It'll bounce back and forth until all the energy is dissipated out, which in a rope doesn't take very long. Now, if you keep sending more waves, if you keep sending more and more waves at the correct frequency, the rope will just look like this. And this wave will appear to go down, this will go up, but it doesn't look like any wave is moving back and forward. It just, this side moves down, this side moves up, this side moves down. Well, the wave really is moving back and forth. The wave really is moving back and forth. It's just moving back and forth at a precise frequency to make it look like you get this one superposition here. So it looks like the crest and trough are just moving up and down. But really, the wave is moving left and right. And it's just moving left and right at precise frequencies to make it look like the crest is just moving up and down. And there are only specific frequencies. This happens only at specific frequencies. Okay, so you could get a standing wave with one crest, one trough, or you could get a standing wave with a whole bunch. All right, so next one. What happens when a wave goes from one medium into another? Now, this is a common example of this is light traveling from air into water. Waves going from shallow to deep. All right, so you sometimes see this in a glass, right? So you have a cup, looks something like this. It's got some water in it. And you put a pencil in it. And the pencil goes like this, looks like this, and then it gets to the water, and then the pencil looks like this. Or a straw. This could be a straw, not a pencil. It's not bent. It's just the water, the light is bending as it moves from the water out. So this is called refraction. Refraction is the way a wave bends when it travels from one medium into another. And refraction with light has very important properties. So when you think about a typical camera, a camera has light that goes from the air into a bunch of lenses, which are made of glass or plastics. And how that light bends is important. If you want a sharp picture, you have to bend that light precisely. Fiber optic cables. Fiber optic cables use refraction. We're going to talk more about refraction in another section in this. But for now, all that matters is when a wave travels from one medium into another, it refracts. Now, there is one more that we didn't put on here, but we're going to put it up here where the interference was. We're going to call this diffraction. Diffraction is the way a wave spreads out after passing through an aperture. An aperture being some type of a hole. Okay, so let's say that we have just a doorway here. Here's a doorway. And there's someone speaking on this side. There's someone speaking on this side. And the sound wave is going like this. Then the sound wave hits this aperture. The sound wave does not continue on just precisely like this, does it? If someone's talking in a room, you got a person right here. Someone's talking in a room and the sound's going through the doorway. If you stand by the doorway, you hear the sound. The sound starts to spread out again after it goes through an aperture. Okay, so the sound wave will start to spread out after going through the aperture. Now this happens for light and this happens for water as well. A water wave, if you look at a harbor, harbors often have big stone walls. This is the top view. Big breakwater, it's called, with a small opening. Right, and waves are coming. So here are the wave fronts. The waves are coming like this. All right, when the waves get to the breakwater, the waves will pass through and they'll start to spread out. Now, naturally, these waves will have much less energy. Right? Because right here, all the energy is in this wave right here. And then as the wave spreads out farther, the energy gets less and less. The amplitude of the wave will go down, or the height of the wave will go down, diminishing it. Right? So that's called diffraction, the way a wave spreads out after it has gone through an aperture. Right, so these things that you should know that waves reflect when they hit solid objects. They impart some of their energy into the solid object, but then they reflect back. Waves can resonate with the solid object, which means they cause the object that they hit to vibrate at their frequency. Waves can interfere with each other through superposition, where two crests, when they meet, will make a supercrest. That's double the size. That's the size of the two added together. Two troughs will do the same thing. A crest and a trough, when they meet, they can cancel each other out. That's wave interference. Standing waves is when waves interfere with each other in such a way so it doesn't look like the wave is moving anymore. Diffraction is the way a wave moves through an aperture or an opening. It starts to spread out after it hits the opening. And refraction is the way a wave bends when it travels from one medium into another. Right, so there are your readings down there. I hope you understood this and that you can recall these examples.